Hello everybody, my name is Attila Marosi and I'm come from the Gulf Hungary. Okay, why? Why do I think that antivirus bypassing could be a good topic? Because all of us use antivirus solutions in the client side, on the server side. So these solutions are extremely used, and traditionally we are rely on them, these solutions. There are very so much malicious content on the white, so we need protection against them. I trust my own experience. I have read so many brochures and information about these solutions, but I like to test this product. So I have created this research. This research was only a weekend, not more than 15 hours. So this is why I think that easy ways to bypass. So if you are boring, you can do it your own, and you can bypass the most of antivirus systems, which is a problem, I think. I want to motivate the vendors to make their job better. And the most interesting question is that who are able to avoid the detection? If anyone can avoid, I think something's wrong and dangerous. What you can expect from this topic? I will bypass signature, simulation, virtualization, sandboxing. So the passwords which are used for these products, and in the defensive side, I think it's easy to avoid. As I mentioned, the whole research was only 15 hours, so it's very easy and fast to develop a dropper, a deliver solution and avoid this product. This presentation is massively technical, so there will be plenty of demos, and I hope that no demo effects will be. The challenge, I would like to test that a well-known shellcode, a well-known malicious content like shell reverse TCP, which is provided by the Metasploit framework, could be hide against these products. I used well-known techniques which are easily to find with Google. Just search bypassing antivirus, you will find plenty of good solutions, and most of them work pretty well. I use the Peter Sear's book, which is the best in this topic, I think. Unfortunately, sadly, we lost this beautiful mind last year. I used virus.total.com to speed up my research, not to compare the vendors and the products, just to detect that which way could be good for the further research. So using virus.total.com could be a good techniques to detect the good way of bypassing, so we can save our time for this. The detection is not equal than the naughty version of the products, but enough good for it. And if we reach a good version, which is worth that the time to test it in a virtual machine, we will test it and figure out its work or not. I use only Windows things, but I think that the essence is the techniques. So it's very easy to implement in other kind of operating system. So the first demo. which is the easiest and cheapest way to create malicious content. Sorry. Okay. With Metasploit, we can generate an executable file with this. Where the L host is the attacker machine and the L port is 18. So I will pretend that I am a web server. And I've used the Metasploit to generate this very dummy file. And it will be good for test, which is the current detection rate for it. I upload it previously to save time. So, as you can see, it's just a few hours ago. This was the file what I uploaded, and the detection rate is 37. So I think it's not so good, because this is very old and we haven't used any kind of techniques to avoid the detection. So we could use, and there are plenty of topics about how we could use the MSF encoder to change the pattern and change the signature of our code. But the main problem with this, that the way and the techniques what the Metasploit use to hide and embed the shellcode to exe is well known by the AV. So we won't reach a good level with these techniques. So there isn't any way. We have to develop our own delivering system to start the code. What could be the easiest way? Sorry. We can extract the shellcode with this. The C parameter will retrieve the C representation of the shellcode, only the shellcode. And I will put the result. Yes, this is the result. I will put it into a C file. This is here. And this is the easiest way to make it run. Create a function pointer. Make it equal with the first byte of the buffer and call it. So this is the traditional way of executing shellcodes. And with this, the result is 23. So the shellcode is the same. The techniques how we make it run is different. And so many antivirus fold because they know and they can recognize the Metasploit, but not the shellcode. So if we extract the shellcode, we can bypass some antivirus systems. Okay. How we could disturb the virtualization system of the antivirus system? We have to create a challenge, but it's a real problem for the virtualization system of the AVs. And the other side, it have to make it clear for the native system. To make it clear, the shellcode is the same, and I put it this one line, which means that str function will search in the argv0 for that string. Argv0 is always filled by the operation system, and the content is always the full path of the application. So it's very easy. My application name is this, and it is compared in runtime. So the operation system will always do this, but if there is some mistakes in the virtualization system of the AVs, they forget to fill this value, this array, and the result of the function call will be less than 0, which means that our code won't be executed. Okay, the result is just 2, what we left behind, but if we test it, our first lucky vendor asset node, this is the first version. So there is no if, it just run the code. Yes, so they have the signatures for the oh. So they know these signatures, this malicious content, and this version have only one line if condition, no detection, if I force the scan, the result is same, and what is much more beautiful, yes. No. Yes. So I got a reverse shell, and there wasn't any. Thank you. There are plenty of vendors who are false with this problem. This is a virtualization problem.
May I give a quick comment? I want to train you on whenever there is a shell popping up, you should give an applause.
Yeah. Yes.
Even though probably he might be a bit like embarrassed. Okay, this wasn't exactly cool so far from the technical level. Still, all of you should know when there's a shell. I mean, depending on maybe the technical.
It's more than enough.
Yeah, but shall mean.
Mm-hmm. So I can control. And where is the firewall? Okay, just go further. But as you can see, there are 20 others who will detect it. So it's not the final version. But what you have to observe is that this is our program. This is the text section for codes, and this is the data section for data. And as you can see, the data for variables for data readable, writable, but not executable. But as you can see, I can execute that code, which is sitting on the data section. It's obvious. And this is because in default, the Windows 7 and 8 use the data protection, DEP, data execution protection, for only the system services, not for every process. No. So, oh, I don't have to zoom it. So the interesting thing is that the DEP is just for the essential process of Windows, not for every process. But if we would like to solve this problem, we have to make this part of memory executable. The easiest and well-used techniques to create a memory which is writable, readable, and executable is to retrieve and request a memory area from the operating system, which has write for execute, read, and write, and we just copy our shellcode to this new memory location and execute it. So it's not to avoid any kind of antivirus, it's just to make our program more stable and good for servers, for example. So if I upload it, the result is same, but the depth is no problem anymore. Okay, we reached the point when we have to start encrypting our payload. We have to this because our payload is just sitting on the file and it's very easy to detect. But if we try the XOR, what is well used in the while and by the virus developer, it's very easy. It's a Intel command, so it's provided by the CP. It's no need to implement the encrypting and decrypting process, and the detection after that will be much difficult. How we can create an encrypted payload? I saved the raw version of my code to a file. This is the byte representation of the code. Yes, and I wrote a little program, a script, which is read all the bytes from the input and XOR it with the provided key and print it out with formats the output. So it's very, very easy. The key would be 4D and just feed the program. And the result is that. As you can see, the result is this 3-4D is the encrypted code of this. So 0 XOR 4D is 4D, 4D XOR 4D is 0. So it will appear if we XOR back in runtime. I put the code, this, and use the same program, and the only change is the key which is provided, and this is the point when I sort back the shellcode in runtime. So until this point, the payload will be encrypted, and after that it will be clear. So, and the result is 3. So encryption is a real challenge for the AVs, because signatures won't work, and we can solve the problem of the virtualization roughly, and the two combination cause that, which is almost good. And that's the time when the second lucky yes, it is Kaspersky. All antivirus are updated today, so it won't a problem. This is the code. I start a listener. And execute. I run 5 virtual machines simultaneously, so that's the reason why it could be a little bit slow, not because the code. Yes. Okay. So,
very good.
And as previously, the problem is if they can detect the code, they could catch it when it would like to reach the network, the other computer. But the encryption and the if statement, it absolutely disturb the system, and they let them go, and the firewall didn't stop me. But there are other products that could catch my activities. So the well-used techniques to avoid the firewalls and other programs which have list about which process has right access for something and which is not. If we would like to pretend that we are a different process, or we would like to exploit a legitimate process, we can inject our code to, for example, the Internet Explorer, and after that, that process will do what we want to do, and not our. It is well used in the wild. There are two main type of it. The first is when we inject a whole DLL to a victim process, or only just a couple of codes. When we inject codes, byte codes, we have to inject PIC, position independent code, like shell codes. But we are lucky because Metasploit provide position-independent code, so without care we can inject it as we want. Very easy to implement the code injection, and we can inject our code all our process. So the victim start our application, all the process we started before, and running with the same right, we are able to exploit and use for our purpose. And in the AV perspective, it's very difficult to emulate and virtualize. And to prevent it, we have to monitor all the API calls to know that which application would like to do something other process. Code injection, basically a legal action. It's very good to hot patch and add some functionalities to other processes, but we need some protection again, with some ability to protect the processes which each other. So this is the purpose where, which is the main reason of the antivirus. So we expect that they will do this. Okay, and if we can inject our code, which will be the good process for our purpose. The good process, the good candidate has a right to communicate on the network. How we can guess which process has this right? We can retrieve a list about processes and the sessions with the API calls, for example, get TCP2, or another way is to use the netstat and parse the text output of the command. And I use the second one. So this is my code. Oh, no. Yes. This is the code. It is encrypted with 6F. It doesn't matter. This is a process to parse the output of the command. As you can see, this is the result of it, and I just cut all the process ID, and after that I try to open all the process with all access, which means I will be able to inject codes. If I can do this, I have the good candidate and I retrieve with the right process number. If I have a correct process, how I could inject my code? I request a memory region from the OS in the space of the targeted process. So not for me, for them. I sort back my code. If I have the decrypted code, I will copy my code to the just request memory region. And after that, I create a new thread, which will run in the name of the victim process, and the execution will start the first byte of the new memory region, which is just filled with the payload. So the victim process will start a new thread, and the code will be what I copy. Okay. And if I upload it, yes, it's still 2. Why?
Scroll down.
Oh. Okay. 2, but why? It's because we use API calls which tagged as malicious. The virus developer use the same function to make their nasty job, and the antivirus products observe the import table, and as you can see, open process, no, sorry, it's not a good directory. Yes. So create remote read, absolutely. Virtual alloc to create a memory for another process, and write process memory. These are tagged as malicious. So if we use this, we will be tagged as malicious. But the import table is a comfort service for the operation system, and there are other ways to retrieve the current address of the process. Which is the easiest? To use the get process address function call. So I created function pointer for the interesting functions, and if I have a good candidate to inject my code, I will request from the OS. So tell me where is this process and this and this. So with this, we can yes. We can clear the import table. Yes. So we can avoid to use this process directly. We will find the good address of it in runtime. And if we upload it, so we reached 0. It's pretty cool, I think. And if we tried it,
From an attacker's perspective.
yes, absolutely. Okay, and listen and start. Now I just make it more secure. Okay, we need a victim process to fill this list, because I don't know which these process which are okay. So for example, so if I start it, it will parse the output of the netstat and try to open all the processes. The listed process are not good for us because I don't have right to inject it. But if use something which is in the same level I am, no, I hope I need some internet connection, but I could bypass. Just to feel it. Yes. Okay. Oh. And now. It's always work well. Okay, in the end I try it again. So if I could inject my code, it try to open reverse shell, and until now it works perfectly. Okay. But okay, I have another candidate. We did this very fast. If if it worked. So to avoid the sandbox systems, usually we could we maybe extend the runtime of the execution, because to observe the activities a process is very time consuming, and it need so much process time. So they have to make a compromise. So many antivirus solutions observe the application from the launch until a couple of seconds, and make their decision. And if you stay the running time much longer, we can you can avoid the detection we keep on the radar with this. So if I put some sleeps into the every interesting cause, I can extend the runtime, and I hope the AVG will make their decision about my activities. Okay, try it again. So firstly, I tried the fast version. I hope it will work. Oh, sorry, there is no victim. Oh my god. Yes. Okay. Yes. Sorry. Okay, the desired functionality would be that I got a process and I just inject, wait 5 seconds every calls, and the first version, the AVG pop up an alert about my activities could be malicious. What should it do? And the second version is would be a long, a slow execution, and after that I got a shell without problem. Okay, and what I wanted to more. The difference between the metamorph and the polymorph codes. Roughly, until now, I developed a code which could be called polymorph, because I changed the way how the original code will be executed, and I do not change anything the essential of the malicious content. So this could be the polymorph code. The metamorphosis code, when you change the command what you are using, and with this you can change the pattern of the malicious content. So there are plenty of possibilities. For example, if you change the XOR E6, which is the traditional way to make E6 equal with 0, but you can use the move E6 to 0, and the pattern of this command will be different, and the result in the execution is absolutely the same. The second, if you push a value to the stack, and usually the push and the value could be a good point to make a signature, because it's long and typical, and not commands, it data. So it's good to make a signature. But I could change it with I generate a random number in runtime. I put it to the stack, and after that I calculate the differences between the original and corrigate the stack value with an additional command with sub or add to make the value same as before. So I wrote it, a script for this. So how we can convert our payload to assembly source? I save the this is the raw version of the payload, and this is the dump of it. This is not an ASM code, it's a dump, so I have to convert it to a code. Yes. So with this script, I convert the dump to a source code. And if I have the source code, I can make modification with this. And as you can see, it generated in runtime and use many random activities. So I will always generate a new version. There isn't any equal than before. So that was the original version, original command, and I created two new, generate a random number and corrigate the value. Okay, and save it to no. Yes. Up. Okay. So I did it previously. So the result will be something. This, I put it, and I will compare this result with the original version. So that is the new. It's 15, and the original, when we didn't change any modification, was 23. So we change the command, we can change the pattern of the application, the code, and it could be because that the detection is decreasing. And combining these techniques, the virtualization bypass, the XOR, changing the commands, equal that we can easily create a new version of any kind of well-known shellcode. So it's very easy and cheap. So not to code a new version of malicious content, just to hide it. I think it's much cheaper. So I'm very sorry about the demos. This is the third time I present it, and until now it wasn't any problem with this. If it's somebody interesting, I will fix the problem and show to anyone if you want it. So that was my presentation, and sorry.